Welcome to Raw Machines, a journey to explore some of the most impressive processes around the world. Today, join me as we follow two very special paths of wood. Inside the factory, it transforms into stable and durable LVL. Outside on the construction site, those engineered beams are erected to become a house. It's a short journey, but enough to see how wood has changed to serve modern life. Let's start now. The journey of the timber begins in the vast forests of North America, where spruce, pine, and fir species have grown resiliently over many years. Loggers appear not as conquerors, but as artisans. They are fully equipped with protective gear and modern chainsaws, yet the most important factor remains experience. Before cutting, they observe the terrain, the tree's lean, the wind direction, and the stability of the surrounding area. A wrong decision not only endangers people, but also leaves a permanent scar on the ecological structure. When all calculations are complete, the first cut is made. It opens up a precise notch at the base of the tree, shaping the path the trunk will follow as it falls. The final cut, deeper and more decisive, completes the process. As the trunk crashes down, the sound echoes like a farewell. Birds scatter, pine needles fly up in the air, and the ground slightly trembles under the weight of decades of growth. It is not an end, it is a change of role. One life cycle closes to open up a new purpose in the human value chain. Not a single part of the tree is wasted. The straightest and strongest logs are reserved for load-bearing beams and engineered wood. Small branches and residual material become wood chips, paper, or biomass fuel. At this stage, the loggers complete their role. They are not merely tree fellers, but the people who lay the foundation for the entire value chain that follows. Now, the wood's journey will be handed over to giant transportation machines, ready to move the wood out of the deep forest and into the world of technology and steel. Heavy-duty logging trucks are a common sight on narrow and steep forest roads. Among them, the Pacific P-16 is a familiar icon of the North American forestry industry. With a gross vehicle weight that can reach hundreds of tons and a powerful drivetrain, these machines are born to conquer terrains that conventional trucks struggle to access. The transportation journey is anything but simple. Winding mountain roads, slippery surfaces, tight turning radii, and steep grades force the driver to precisely control speed and load. Every curve is a test, not only for the vehicle, but also for the driver's experience and concentration. The final destination of this journey is the West Fraser LVL production plant in Sutherland, Oregon. Here, wood is no longer viewed as individual logs, but becomes a strategic raw material for modern construction. Now, let's move deeper to see what makes this factory so special. At the log yard, heavy logs are unloaded using large machinery. Afterwards, the debarker cleans the bark layer off the log. The clean logs are then moved onto the feed deck of the Veneer block cutting station. A gigantic sharp saw blade slides through, cutting the trees into several uniform blocks. The sound of the saw shrieks loudly, but behind that sound is the perfection of order. From a free, indeterminate shape of nature, the wood is reshaped into standardized units, ready for production. The cutting station may not be the most showy part, but it is where the foundation for the entire process is laid. In 2014 alone, West Fraser processed over 213,000 cubic meters of wood, producing nearly 1.9 million 8-foot veneer units. Those numbers are enough to speak to the efficiency and power of this initial stage. Following the block cutting stage, the wood is transferred to hot water vats for heat treatment. Under the effect of steam and high temperature, the wood fibers become softer and more flexible, facilitating the veneer peeling process. When the necessary softness is achieved, the wood is moved onto a cleaning conveyor. A rounding lathe quickly removes the rough outer layer, exposing the lighter colored wood core inside. In the next step, a spindleless veneer lathe continuously rotates the wood block, producing a continuous thin veneer ribbon approximately 1/8 inch thick. The initial heavy log is transformed into light, thin, workable veneer sheets, ready for the drying and pressing stages. That is the value that technology brings. Natural defects found in rough-sawn timber, such as knots or twisted grain, are eliminated, replaced by uniform veneer sheets with stable structure and precisely controllable durability. The long, thin veneer sheets, after being peeled, cannot be immediately used for LVL production. They need to undergo cutting and sorting before continuing their journey. The automated cutting system works with high precision, dividing the veneer into standard 4/8 foot sizes. The requirements at this step are very strict. The surface must be flat, the edges must be straight, and the dimensions must be uniform to ensure that when layered, the sheets fit together perfectly. Next is the inspection stage. The veneers are categorized based on quality grade and moisture content. Those that meet the standards continue to the drying stage, while those unsuitable for LVL are redirected to other wood product lines, where technical requirements are lower but still effectively utilize the material. A notable aspect is how the factory handles the residual waste. Log cores, after peeling, the cores are chipped or reprocessed to supply other facilities. Wood chips, yar splinters. The chips generated during cutting and peeling are sent to pulp mills, where they become raw material for the paper and packaging industry. Bark and sawdust. These become biomass fuel, providing energy for the very factory that created them. It is a closed loop where every wood fiber is valued. When a tree is harvested, its value is not lost. It merely transforms into various forms, balancing economic benefit with environmental responsibility. Despite being carefully cut and sorted, the veneers still retain the moisture of the deep forest. If they remain in that state, they will warp, shrink, or crack when subjected to gluing pressure. Therefore, drying becomes an unavoidable challenge on the path to becoming LVL. In the kiln, a high-intensity stream of hot air at about 400 degrees is blown through the veneer layers. In just 3 to 4 minutes, the wood's moisture content is brought down to the standard level. The roaring wind, scorching heat, and faint smell of resin create a harsh but sacred working environment. The crucial factor lies in balance. Wood that is too wet will destroy the glue bond, while wood that is too dry becomes brittle and prone to cracking. Only when the standard moisture content is reached can the veneer layers bond durably and maintain a stable shape over the long term. Having passed the drying stage, the veneers have completed a vital preparatory step before entering the pressing phase, where the true value of LVL is formed. The layering process on the conveyor belt marks the most critical moment for LVL. This stage, known as lay up, is when the material's mechanical structure is determined. Ultra-durable adhesive is uniformly applied to each wood surface. Unlike natural timber, which is often unpredictably strong or weak, here, every wood grain is arranged in parallel. When all grains face the same direction, they no longer compete but become a unified collective, reinforcing and sharing the load together. After the layering is complete, the entire stack of veneers is fed into a continuous press. The system of steel rollers and press plates generates pressure up to 300 psi, while combining high temperature and microwave energy to activate the adhesive, tightly bonding the wood layers. The resulting products are LVL billets up to 60 feet long, tens of layers thick and weighing tons. But the miracle is not in the size, but in the uniformity. No knots, no cracks, no deformation, only strength controlled by technology, no longer dependent on the randomness of nature. Although already strong and monolithic, LVL still requires one final finishing step before it can appear in construction projects. Much like a rough gem must be polished before it can shine. The LVL billets are cut according to the required dimensions of each specific project. Every beam undergoes rigorous technical inspection, is clearly stamped with specifications, and has traceable origins. Only when all standards are fully met do the products leave the production line. Finally, when all stages are complete, the LVL is bundled into lots, loaded onto trucks, and sent on its way. Half heads to Canada, the other half to the United States. Then, in thousands of construction projects, they appear in places few people notice, silently resting above door frames, serving as sturdy beams, quietly supporting the spaces where people work and live. Leaving the factory, LVL does not end its journey, but merely changes its context. From a material controlled by technology, it steps onto the construction site, where strength only holds meaning when placed in the correct position and sequence. And there, every structure begins with the foundation. Before the first timber plank is laid down, the foundation must achieve absolute precision. Whether it's a frame subfloor or a concrete foundation, the first course of timber is always placed on a sill gasket to protect against moisture and ensure the airtightness of the entire structure. Each piece of timber is clearly coded with numbers and letters printed on both ends. The construction crew reads the code from the outside in, left to right. This symbol identifies the wall location, the timber course, and the order of the plank, all accurately reflected on the design blueprints, which helps the erection process proceed systematically. The first course of timber is always a half course, with the planks cut in half to create the reference mark for the entire structure. If installed on a framed subfloor, these planks are fixed using dowels provided with the material package. If installed on a concrete foundation, the construction crew drills holes into the timber and uses standard anchor bolts to secure them firmly. The maximum length of each timber plank is about 16 feet. For longer walls, the exclusive timber lock joint system is used. This is a self-tightening mechanism based on gravity and geometry, not a complicated connection. When joined, the connection virtually disappears. In just a few seconds, a seamless wall has been formed. Each dovetail joint is sealed with a combination of foam, weather stripping, and sealant. 3 layers of protection are simultaneously formed, against water, against air, and to limit heat loss. The sealant must be applied neatly to the edge, not overflowing nor recessed too deeply. After placing the seal, the next course of timber is laid and secured with dowels or screws. The screws are driven in at an angle, perpendicular to the dovetail joint, and slightly recessed to allow for the natural settling of the wood over time. This process is continuously repeated around the entire perimeter of the house. No joint is overlooked, whether it's a full course or a half course with a lock. The result is an airtight structure, which significantly reduces heating and cooling costs and eliminates drafts. The timber planks are designed with a double tongue and groove system. The tongue uses a butyl gasket with a paper liner, while the groove uses a single foam gasket. During construction, the paper liner should only be peeled off immediately before placing the timber course, and waste must be managed neatly to ensure site safety. At the corners, holes are drilled through from the top course down to the bottom course. Expanding foam is injected into about half the volume of the hole, just enough to seal it without causing back pressure. The goal is to completely seal the dovetail joints at the corners, the most easily overlooked locations. No timber course is allowed to lack a sealing layer. The continuity here determines the long-term durability of the entire structure. The timber planks are stacked as close to their installation location as possible. Long planks are stacked on the subfloor, and short planks are stood upright to save space and facilitate access. When a slight tap is needed to lock the joints, the construction crew always uses a block or scrap wood, avoiding damage to the surface. The electrical system has already been pre-drilled and routed within each timber plank. Outlets, wires, and switches all have their designated paths. This significantly reduces time and on-site intervention. Most walls can be erected by hand, but as the walls grow higher, the weight and length of the timber planks become a challenge. At this point, sturdy ladders and scaffolding are mandatory, and working as a team becomes a safety rule. Multiple people lifting a timber plank is not only faster, but also safer. This is the clearest moment that shows the house is not built by an individual. Anchor holes are drilled 60 inches apart, 12 inches from openings, corners, doors, windows. The top log is smoothed by removing the tongue and groove to create a flat base for the beams or trusses. The anchor rod is cut to fit the length from the wall top to the bottom hole, plated and set in place. Bolts are tightened regularly during construction. The last tightening happens before the baseboard trim is added. The spring compression system involves compressing the rubber by about 2 inches. This holds the structure tight while still letting the wood settle seasonally. Doors and windows are not installed directly into the timber planks. They are secured to kiln-dried, solid wood splines, which allow the surrounding timber to expand and contract without binding the frames. The splines are recessed inwards by about 1 to 2 inches. The window door openings are pre-milled at the factory. The final cutting is only performed after the wall is complete and the through bolts have been tightened. The felling of a tree, in the modern context, is no longer a simple act of exploitation. It is the result of long-term forest management, of decisions carefully weighed between the demands of construction and the limits of the ecosystem. When timber leaves the forest, it enters the world of mechanics and transport. The treacherous forest roads, the trucks weighing hundreds of tons, and the machinery that has served for decades all reveal a simple truth. For natural materials to be present in modern life, a great deal of unseen effort is required behind the scenes. In the factory, wood undergoes its most profound transformation. From an inconsistent natural material, it is peeled, dried, rearranged, and pressed tightly under heat and pressure. The result is not a denial of nature, but a way of reorganizing it, where imperfections are dispersed, strengths are amplified, and mechanical properties are strictly controlled. However, technology is not the endpoint. When engineered timber members are brought to the construction site, the story returns to people. Erection is not just assembling components according to blueprints. It is a process of understanding the material, respecting tolerances, and accepting that wood remains a living entity, expanding, settling, and reacting to the environment in its own way. In self-assembled wooden house kits, every log course laid down bears the mark of the builder. Every carefully sealed joint is a choice for long-term sustainability. The seemingly minor details are precisely what determine whether the house will remain stable through many seasons. This film does not say that technology replaces nature. It shows the opposite. When nature is properly understood, responsibly managed, and combined with technical intelligence, wood can continue to live, not as a tree, but as a durable part of the human-made world. In every wooden house, the memory of the forest still remains. And in every building decision today, there is a question for tomorrow. How do we choose to use resources so that they not only serve the present, but are also worthy of the future? Thank you for listening to the end of the story. If you also enjoy similar videos, please hit the like button, share, and subscribe to the channel so you don't miss any exciting stories to come. Raw Machines says goodbye and see you again.